I made a mistake. So what did I do? This right here should be a plus. So let's fix that. That should be a plus. Should be a plus there. And what does that do? It changes my t squared term on top to minus 9 t squared. And as a nice calculus student, I factor that numerator. That is going to be useful later. All right, there's my velocity function right there. Next, where's the velocity after 1 second? So this will be d prime with 1 plugged in. So I use this function, nicely factored. I get 9 times 8 over 10 squared. That looks like 0.72 feet per second. Easy peasy. 4. When is the particle at rest? Well, I'm going to take my derivative and set it equal to 0. Okay, at rest means velocity is 0. So what do I got? 9 minus t squared all over blah 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 blue 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 blue. So this equals 0. So I got a fraction here, and it is 0. How is that possible? Well, the numerator must be 0. So 9 minus t squared must be 0. So I get 9 is t squared. So t is plus or minus 3. But I'm going to throw away the minus, because in physics, well, in this example, we decided that t is bigger than or equal to 0. When is the particle moving in the positive direction? So I want d prime of t to be bigger than 0. What does that mean? That means that this item here must be positive. Bigger than 0. Okay, how do I know when that is 0? Or how do I know when that is bigger than 0? Well, what I should first do is find out when it is equal to 0, which I've already done above. I found that when t is 3, or minus 3, this guy is equal to 0. So what I usually do is I use what's called a number line for t. And I say minus 3 is on there, and plus 3 is on there. These are the t values at which I know this equals 0. So, and those are the only ones. So all I need to do is classify the remaining intervals. Now I should remember that we decided above that t is bigger than 0, meaning I don't care what's happening over here. So I'm going to classify these intervals, these two, this one and this one. I'm going to classify them as either giving d bigger than 0 or d less than 0. And how I classify them is by using what's called test points. So how about this first interval, 0 to 3? What I do is I choose a number at random in here. Well, not at random. I choose a number here plug it into my derivative and see if I get a positive or negative number. So I'll do something nice and easy. I'll go d prime of 1 is, what's that? Well, I got 9. When I plug it in here, right? I get 9 times a positive number, all divided by a positive number squared, right? I don't have to actually calculate these things. This is a, sorry, just to be clear, this is a plus sign, and this is a plus sign. So I'm just trying to determine whether d prime of 1 is positive or negative, and I can see that it's positive here, because I have positive number divided by positive number. So over on my number line, I can write d prime greater than 0. And now for the next interval, I'll choose, say, 4. d prime of 4 is 9 times a negative number, all divided by a positive number squared. So that will be negative. So I know here d prime will be less than 0. Okay, let's go through the reasoning one more time. I'm trying to find when d prime is bigger than 0. I first of all found out when it equals 0, and then I decide what's happening on either side of that t equals 3. And I do that just by plugging numbers in here to see what's happening. I chose a number in here. I chose 1 because it's easy to work with. Plugged it in here, got a positive number. That told me that here I got d prime bigger than 0. To classify this interval, I chose 4. I could have chose 14 or 63, but the point is I need to determine whether d prime is bigger or less than 0 over here. So I did that. Now I can answer my question. My question is, when is it moving in the positive direction? That is this guy here. So the interval is going to be zero less than or equal t less than 3. So at 0, you'll notice if I plug 0 in here, I get a positive number. So at 0, the particle is moving in a positive direction, so therefore this inequality is not strict. At 3, my inequality is strict because at t equals 3, my velocity is 0. Okay, my particle is not moving in the positive direction.